Recorded is rolling. It is Friday, May 8th. You guys have your exam review packets. We're gonna finish this today. So, where we left off, we were starting the probability section. You guys remember module 10 in your textbook was probability? So we've done some of those. I think we did this arrangement of the cans. Yeah, we're about to do. There are 30 dogs participating in a dog show, and then gold, silver, bronze, and then 30 dogs in dog show. Well, let's say they receive Scooby snacks, which is not rank order. Okay. Now that reminds me of one of those is permutations, one of those is combinations. Okay, see if you guys remember that's going to be the first two questions on the Kahoot. Still got a few module 11 makeup quizzes going around. So yeah, when everybody takes those, okay. I do want to get those back to you guys as soon as I can here. And then don't forget too, your 90% goal is coming up due in about 12 days. All right, let's go Kahoot. Let's go to the dog show. To the dog show. Plus that.
So it's going to be a knowledge jump.
Here, I'll make a note. No,
It's in there. It is. Yeah, I see my last one.
We're gonna have a printout of the combinations.
Yes, exactly what is printed on your study guide. Those formulas for the probability. Same thing's going to be printed out on the final exam. You just have to know how to apply these. All right, so let's take a look at this one. We got 30 dogs participating in dog show. There's going to be gold medal, silver medal, and bronze medal, which sounds like permutations because the rank order matters. If you're getting gold, you're not getting silver and so on. So here, if I do this from scratch, you got 30 dogs in dog show. Guys, couldn't any of 30 dogs win the gold?
Yeah.
Okay. But once you've won the gold, then how many dogs are remaining to win the silver potentially? 29. Okay. And then once that's occupied, then how many could win the bronze? Yeah, any of 28. Okay. Now that right there is the answer. Here. Right. So let's keep that to 30, 29, 28. Okay. This comes out to there are 24,360 different ways to award these medals. Okay. But there's also a more formulaic way to do this. Okay. And it's this permutations right here. See where it says n factorial over n minus r factorial? So that would be like there are 30 dogs, that'll be 30 factorial. Okay. There are 3 awards, gold, silver, bronze in that order. So it'll be 30 minus 3 in that factorial. Okay. Hey guys, is that 30 factorial over 27 factorial? Which is like 30, 29, 28, 27, all the way down. 27 factorial is, of course, 27 all the way down. Okay. Hey, look, that is the same thing. It's the same thing. Is that? Okay. Finally, here's a lot of you can. The calculator will do this whole process for you anyway. Just type 30. Everybody has this model calculator within reach, don't you? Okay, type 30 for 30 dogs. Then hit this probability key. Okay, the first option is permutation. So we're going to choose permutations, NPR. And then we'll say 3 metals. And there you go. Okay. There's yet another way to get the answer. So you can reason it through and get the answer. You can apply the formula manually in the calculator, or you can just have a calculator do the process. Okay. Every time I'm getting 24,000 and so on. Okay, you guys go with permutations? Okay. Now the next question is, right, let's say we're just awarding dog snacks, in which case the order doesn't matter. Just 3 dogs get snacks. Now what? All right, and nobody got that either, huh? Okay. So, Now we're just awarding snacks and the order doesn't matter. That's not more like combinations, which is a pretty similar looking formula, but now there's this R factorial here. Okay? The reason we're divided by R factorial is that there's fewer possible combinations compared, like see, with the metals. Like you could award gold, silver, bronze to dogs A, B, and C, or maybe dogs B, C, and A, or gold, silver, bronze, right? Which is a different set. That's why there's going to be more permutations and combinations. The snacks, it doesn't matter. You could rearrange the snacks, and it doesn't actually change the outcome. Okay. So let's try it. 30 factorial divided by 3 factorial 27 factorial. Do that. Okay. And that tells me 4,060.
You don't want me to give it to you. I don't want me to give it to you.
Here, put in a fair trade. I will get that later. Thank you. Yeah. So there are 4,000 and so many different ways to award the tax. Okay. Or, again, the calculator will do this for you. So type 30 for 30 dogs. Okay, you guys all do that? Your calculators? Within reach? Hit this probability key. Go over to NCR for combinations. And then type 3 for 3 dogs for receiving snacks. And it still gives you the same thing. Okay. Right, so we've only done 2 Kahoot questions so far. We did permutations where the order matters, gold, silver, bronze. We just did combinations where the order does not matter. We're just awarding a bunch of snacks, a bunch of dogs. Are you guys good with permutations and combinations? It's all in your notes. All right. There you go. Roll a fair 6-sided die. What's the probability of rolling an even number? Guys, okay. Here, we'll show you guys.
Use the bathroom. Or not the bathroom. Can I get a pencil?
Here.
Thank you, Shane.
Yeah. All right, so here's the die. Maybe got some numbers on this thing. Over. All right, so whatever numbers there. Right. And so you could roll any of these numbers. 1, 2, 3, 4, 5, 6. Yeah. Okay, so here's some even numbers. And here's some odd numbers. Right. So you guys see 3 evens and 3 odds. So the chance of rolling an even number would be 3 out of 6, which reduces to 1/2. So you guys know there's a 50-50 chance of rolling an even number. Let's try. Ooh, all right. Dominic, it's a point. How about an odd number? Guys, what's the probability of rolling an odd number?
You get
All right. Better. Okay. Yeah.
What is that?
No,
The answer is things
over
over
here. All right.
1, 2, 3. No.
No.
Okay.
Oh, yes.
So you guys know there's a 50-50 chance of rolling either an even or an odd. Okay. Now, really, those 2 questions are a setup for this next question, which is expected value. Right, you guys ready for expected value? I didn't actually print this formula on your page, but I think you can reason this out. If you play this game 100 times, are you gonna win, lose money? All right. So we got a fair die, 6 sides. 1, 2, 3, 4, 5, 6. You pay $10 per roll to play the following game. If you roll an even number, you win $2. If you roll an odd number, you win $15. So is that a game that you should play?
Are we supposed to turn in on packets?
No, this is just for you to study. And then the final exam looks nearly exactly like these questions. Okay. So let me show you guys why it's a bad idea to play this game. Okay, bad idea to play this game. So this is called expected value. Okay. Now, the first thing I told you is that you have to pay $10 to play this game, to roll the die. Is that true? You pay $10 to roll the die? I do have the dice here. And that's the model going. Right. So you pay $10 to roll the die. So I think I'm going to lose $10 100% of the time, guys, 100% as a decimal, is that called 1.00 or just one? Right. So 100% of the time, I'm going to lose $10 just by rolling it because I have to pay $10. Okay. Then I'll say plus. Now, if I roll, how'd it go here?
It was even as get to odd.
Yeah, okay, even you win 2, odd you win 15. Okay. So even you win $2, so I'll say plus $2, and that'll happen 50% of the time, or 0.50. And then odd you win $15, that'll happen 50% of the time. Okay. So 100% of the time you're losing $10 because you have to pay $10 to roll. Okay. And then depending on what you roll, you win different amounts. So let's add it all up and see what it comes out to. Negative $10 times 1 plus 2 times 0.5 plus 15 times 0.5. Okay. I'm getting negative $1.50 per roll, right, on average. Right? So guys, if you played this game 100 times, you just keep rolling this die like, hey, I'm winning, I'm winning, I'm winning. But you had to pay every time you roll it. Okay? You're losing $1.50 per roll on average. So if you play this game 100 times, you've lost how much money? Yeah, 150 on net on average.
If you win.
Okay.
If you win, you need to play.
Well, okay. In the long run, statistically, you're never going to win this game. This is a yeah. All right. This is how casinos get your money.
Good thing I'm supporting them.
All right. What's the probability of winning a 100 choose 5 lottery? Okay. Lottery has 100 balls. You're going to choose 5. If you choose all 5 correctly, then you win the grand prize. You buy 1 ticket. What's the probability of winning the lottery? 100 choose 5.
I don't know, Virgin was England. I did, but he's a Jane member, so it's okay. He's drinking his game affiliated faster.
It's 1 in 75 million. We convince you guys that's true. 1 in 75 million. So we have a 100 choose 5 lottery here. Okay. Now, I gave you guys in this box a 20 choose 5 lottery, and if you know how to follow this and change out the numbers from 20 balls to 100 balls, you can get it. Okay. But actually, there's another perspective too. If you're just looking at the grand prize, which you can actually think of this as a combinations question. You say, well, how many combinations of 5 balls out of 100 could I possibly choose? Because that will also get you the answer. Because the probability of winning would just be 1 over that. Okay. So you could do this. You could do NCR. So let's do 100, choose 5. Okay. And I showed you guys earlier how to do that with the factorials. You're looking at right there. Okay. Or you can have a calculator. You type 100, probability, go NCR for combinations, and then 5. Okay. And yep, there it is. It's 75 million and, well, 75 million. So 75 million. Yeah.
Why did I get a new test?
Because you have like 3 questions answered, so I'm just starting from fresh.
Okay.
All right. So guys, wouldn't the probability of winning be 1 over that? 1 in 75 million? Okay, so you think of it that way? Okay. Or let's say you want to follow this. I'll show you guys the same thing. So, okay, you're choosing 5, so same as the premise here. Okay. And you want to get all 5 correct. So isn't that like 5, choose 5, and then multiply by. And here's how many incorrect. Now, guys, if there's 100 balls, aren't there 95 potential wrong balls you could choose? Okay. And you want to choose none of those. So it's 95, choose 0. And then over 100, choose 5. Okay. Guys, watch this. What is 5, choose 5? 5, NCR, 5. It is 1. Yeah. So this number is equal to 1. And what is 95, choose 0? Guess what that is?
Yeah.
Also 1. Okay. Because there's one way to choose no incorrect balls. There's one way. Okay. So it's 1 times 1 divided by, hey, that's just this right here. It's the same thing. You guys see it's all the same thing? Okay. So on the final exam, I will just ask a version of that question. on your quizzes, I asked a question like, well, what's the probability of like getting 4 right and 1 wrong? But that won't be on the final though. Yeah.
As you just said, 4 right, 1 wrong. Wouldn't that be the same chance of getting all 5 right because the balls are arbitrary?
No, because there are 95 different ways to choose one of the wrong ones. So it's a lot more likely. Like here, if you have a lottery ticket and you get all 5 right, that's extremely rare. It's 1 in 75 million. If you get 4 right and 1 wrong, that's a lot more likely. There will be many, many, many more of those tickets. Yeah, yeah. So you would change this to 5 choose 4. Now 5 choose 4 comes out to 5 actually. 5 choose 4 5. Okay. And then because you could choose incorrectly in any one of the other 5, right? That's why it's 5. And then this would be 95 choose 1, which comes out to 95. Yeah, so this would be 5 times 95 instead of 1 times 1 in the numerator. Yeah, yeah. Okay. So it's a lot more likely that you have a lottery ticket that has at least 1 wrong.
No.
What if you
Yeah, what if you beat those odds?
then you have lots of money.
But don't gamble.
All right, matrices. So we're looking at matrix F here. Let's all get this one right. Guys, element 1, 2. That's first row, second column. Is that number right here? I'm circling it. That's first row, second column. That's how you read that, right? 1, 2. Element 1, 2. Everyone's gonna choose this one right here. Element 1, 2. Okay, so everybody knows how to find element 1, 2. It's first row, second column.
Yep.
All right, now that you know that, series of matrix questions that are all referring to element 1, 2. What's element 1, 2 of, let's say, C plus D? Okay. Here's 1, 2 on C. Here's 1, 2 on D. Yeah, let's just do this one together too. Guys, here's element 1, 2 on C. Here's element 1, 2 on D. Can you guys add those together? Hmm. Hmm. It might be. Might be.
You going home?
11. Okay, so you guys can add elements together. All right, 2 by 2 matrix, another 2 by 2 matrix. Okay,
Here's what now.
add like elements. Okay, now let's go 3e plus 4f. All right, so here's e, here's f. Okay, we're still focused on element 1, 2. 3e plus 4f. Guys, what's 3 times 2? 6? Here, jot down 6. What's 4 times 16? That's 64?
Yeah.
All right. What is 6 plus 64? All right. You guys can do 3 of something plus 4 of something. You guys do that. All right. It's all focused on element 1, 2. Is there any question about that? All right. Guys good. Guys good. All right. How about 2c minus d? Same thing. We're focused on element 1, 2. Okay, so we're back up to these 2 by 2 matrices. Let's do 2 times 9. Guys, what's 2 times 9?
18.
Okay, and then we're going to do minus 2. Yeah, what is 18 minus 2?
650.
Do you guys see where I'm getting that from? All right. All right. Does anybody need me to write any of these down? You guys good with how we're doing it? You guys good? All right. Okay. A times B. Four. Let me show you guys what's 4 here. Okay. Right, so here's matrix A, matrix B, multiply them together in this order. Okay. Right. So this is a 3 by 1 matrix. This is a 1 by 3 matrix. Okay. The fact that this one matches this one means you are allowed to multiply these together. Okay, and then the solution matrix is going to be these outside numbers, so it's going to be 3 by 3. Now you don't actually need to multiply the whole thing to get the answer, but I'll show it to you anyway. Okay. So I know this is going to work out to the 3 by 3 matrix. Okay. So element 1, 1 of the answer, I need first row and first column. So let's do 1 times 3. Guys, what's 1 times 3? 3. Right. Let's move over to the next column. What's 1 times 4?
4.
4. That was the answer, wasn't it? Okay, that's all. Actually, that's all you need to do. Okay, but here, just for completion here. Can I slide over? What goes right here? 6. Right. Now let's go down second row. This times this is what goes here. What goes right here? 8. What goes right here? Is there any question where these numbers are coming from? Let's go third row. Now I'm working from this 5. What goes right here? 50. 5 times 3. How about right here? 20. And right here. 30. All right. So you guys can definitely multiply matrices. That's good. 3 by 1 and 1 by 3.
I'm so proud of you, Con.
Thank you.
All right. Nice job. Nice job. Ooh, let's do this. D times D. All right, let's check this out. So I've got a 2 by 2 and a 2 by 2. So 2 by 2 matrix here, 2 by 2 matrix here. Yes, I'm allowed to multiply them, and the answer will also be a 2 by 2 matrix. Okay. So remember, multiply matrices like this, you have to go across the row on the first matrix and down the column of the second matrix. You guys remember that? So guys, 5 times 8, is that 40?
Yeah.
So I'll drop down 40, but that's not the whole thing. Plus 9 times 6 is 54. So it's 40 plus 54. Right. Now that's element 1, 1. I said, so first row, first column gives me that. Whatever. Okay. Now, next column. 5 times 2 is 10. Plus 9 times 7 is 63. Okay. Which that'll lead to the answer. Okay. So if I ask for element 1, 2, you got the first row on the first matrix and the second column on the second matrix.
Wait, so it's 5 times 8 and then
5?
9 times 7?
Yeah, it's 5 times 2 plus 9 times 7. Right, that's where that came from.
Okay.
Okay. All right, and then just for completion here, I'll do 4 times 8, which is 32, plus 3 times 6 is 18. Okay, and then last one, 4 times 2 is 8, plus 3 times 7 is 21. Okay. So just give me what 94 here, 73 here. It's 50, and this is 29. You did that right. Right? Got it?
Wait.
Now since I asked for element 1, 2, then that's the answer right there.
The 9 times 7.
Yeah.
So it's 5 times 2, 5 times 7.
Yeah, so if I'm asking for element 1, 2,
There's 5.
that's something about the first row and something about the second column.
There's 5 times 2. That's 9 times 7.
Yeah. 5 times 2, 9 times 7, add them together.
Yeah.
Right, you're always going across the row on the first one and down the column on the second one. Look at those matrices. All right, you guys can multiply 2 by 2 matrices. It's good.
Freaking awesome job.
By 2 matrices.
Hey, don't do it. Are we?
All right. How about E times F? All right, see how to get that. So we got 3 by 3 times a 3 by 3. You can do. Now, I asked for element 1, 2 for the answer. So yeah, you could multiply this whole thing out. It would take a while, but the shortcut is you can just hone in on this specific element for the answer. Okay, so element 1, 2, doesn't that refer to the first row of the first matrix and the second column of the second matrix? Hence 1, 2. Right. So all I need are just the numbers I just circled in pinky right here. I can just all into that. So you got 6 times 16 plus 2 times 9 plus 14 times 12. Let's see what that is. I'm looking at 282. Yeah, that looks right. That's the answer. All right. You guys can multiply 3 by 3 matrices. That's good. That's good. Determinant of matrix B. Oh. Okay, let's check this out here. What was let's take a phone call there. 5943. Okay. So we got 5943. Okay. Now, a lot of times for the determinant of that matrix, you'll just see this is with bars, outlining bars, 5943. Okay. Because there are a few, map this on a grid, right? This could be like the area of parallelogram, but there's different ways to interpret this. Okay. But the determinant, I'm going to look at this diagonal, and subtract the products. So that's 5 times 3 minus 4 times 9. 15 minus 36. Negative 21. Right, so you guys go to finding the determinant of a 2 by 2. Find determinant of a 2 by 2. Okay. Right, success. Yeah. So 3 by 3 matrix. There are a few different ways to get the determinant. What you're both focused on is the method that I'm going to do with you guys right here, which is take the first 2 columns and copy paste them out here, which you do like that. Let's start looking at these diagonals. So I have these diagonals that I circled in pink going this way, and these other diagonals I circled in blue going this way. And what I want to do is add up all the products of those pink diagonals, which I've got started right here. Okay, and then the products of the blue diagonals, and subtract those out. So let's see what it's going to be.
So is it gonna be a negative?
6? Yeah, it can be negative. I think this one will be. Right, 19 plus 2, 3, 11 plus 14, 10, 8. Okay. So I'm getting 3,238 minus, all right, and then all this stuff. Let's see what this
Bad boy.
11,
Bad boy.
18, 14, 8, 3, 6, 19, 10, 2, 3,296. So it's 3238 minus 3296. Looking at negative 58, which is the answer. Right, you guys can find the determinant of a 3 by 3. You guys good. That's good. All right. And last question. Last question. Can you take the inverse of matrix C?
That was 7. You want me to go 7?
Yeah. No. Yeah, cool. Yeah. Thanks.
What are you
Only then I was supposed to have a meeting where I'm
Yeah.
Yeah, that was 45. Yeah, but no, sad because you're a girl.
I'm missing her in that portion.
That's what I said. I know. You know. That's not nice. I don't agree first order. Dies because they need to for a long time. There's this really good French reference No, what do you think? Understanding. It's perfect. I mean, I scored. Why? No, it's not the things that. I scored. But you're not gonna be like, you have your best. I don't think a guy cares. It's not too open to about it. Your friends are there. That might work.
All right. So yes, here. So take the inverse of a 2 by 2. One step of the process is you to find the determinant, but we did do that a couple of questions ago. You guys remember we found the determinant of matrix C was negative 21? You guys remember that? Okay. So jot that down.
Okay.
And then the inverse of matrix C is 1 over the determinant times. And then you set up a new 2 by 2 matrix. You swap the elements, A and D, or 1, 1, 2, 2. Right? So this 5 and 3 become 3 and 5. Okay. And then elements B and C, 2, 1, 1, 2, stay in place, but they become negative of each other. Okay. Finally, since I asked for element 1, 2 of the answer, you find element 1, 2. So it's negative 9 or negative 21 in this case, which reduces to that.
That's
Alright, that is it. That is it.
Names disclosed.
Alright, with the bronze, Lydia, the silver, Aiden, and the gold, Dominic.